Hi, in today's video we're going to be talking about the reaction with alkynes. So these reactions are quite similar to the reaction with alkenes, but because alkynes have two sets of pi bonds, they're going to undergo these reactions twice. So when an alkyne, in this case a terminal alkyne, it reacts with an acid, it not only adds the halogen once, but adds halogen twice. So that's often what we see in the product, but in reality it's also adding the proton twice. So again, the convention is not to draw those protons in. I'm drawing them in for the sake of the mechanism here. So just like with alkenes, the first thing the alkyne does is react with the proton of the acid. So the alkyne acts as a nucleophile. The electrons in that double bond act as a nucleophile, and it generates a carbocation. Now this carbocation is not very stable, but it is the most stable possible because it is the most substituted carbocation. So the halogen then reacts with the carbocation to give you this alkene halogen product. This goes on to react with the acid once again, and it generates the more stable carbocation, and that is the carbocation that's most substituted, and it's also the carbocation that if there was a chance where there was multiply substituted, so like a secondary carbocation versus a secondary carbocation, the one with the halide already bound is going to be the more stable, and that's because the electrons in that halide can donate a little bit more electron density than a standard carbon-hydrogen or carbon-carbon bond. So now, again, similar to an SN1 reaction, the halide with a negative charge will react with the positive charge and give you now this product where both halogens wind up on the same carbon. So the types of strong acids that we use for this are HCl, HBr, and HI. Now let's look at when we want to add a lot of halogens to an alkyne. So this is going to be a halogenation reaction, and this is similar to the halogenation reaction that you saw with the alkenes. So if an alkyne reacts with, for example, XX, this could be bromine, Br2, or chlorine, Cl2, it ends up with 4 halogens across that triple bond. And just like in the case of the alkene, the nucleophilic alkene interacts with one of the halogen atoms, which breaks the halogen-halogen bond. And this, unlike a proton where there aren't electrons, this has electrons, and so it can come back. And this forms a halonium ion. So this could be bromine, this could be chlorine, but let's say it's the bromonium ion and the other halogen. That halogen, just like in the case with the bromonium reaction that you saw in a previous video, interacts with where the more stable carbocation would be, so the most substituted position, and it gives you this dihalogen alkene. This goes on to react with another equivalent of the halogen, like Br2, to give you another bromonium ion, or halonium ion, and this again is trapped by the X minus in this case to give you your final product where you have complete halogenation of your alkyne. I look forward to seeing you next video where we look at another example of alkynes reacting similar to but slightly different from alkenes. Thanks.